Point 3, we're going to talk about rates of change other than motion. So these are the types of problems that I will refer to minus rate out problem. Rate in minus rate out. In minus the rate out. Derivative of the amount that you have. An amount and you take its derivative, you're going to get a rate. So the rate, let's look at example number 1. You're going to need your calculators, as I said on the website. You have two different rates. There is snow on Janet's driveway when the snow begins falling at midnight. Well, there's no snow, I should say. The snow accumulates, so this is going to be your rate in. The snow accumulates, that's modeled by f of t, and then Janet removes the snow off her driveway, and that's modeled by g of t, and that's after the time after midnight. So you have a rate in and you have a rate out. So stop the video and type this into your calculator if you want to. These do not have to be typed. So in this particular one, it's going to say, find the rate of change of the volume. Rate of change of the volume. Well, they give you the rate. They give you the rate on and they give you the rate off. First derivative rate. Just like in the last section, we have position, then we have velocity, and then we have acceleration. Change of the volume, they're giving you the first derivative. So that's going to be your rate. The first derivative is your rate. In this case, velocity. We have our rate in minus our rate. They want to know, and oops. 8 a.m., so that's 8 hours after midnight. F evaluated at 8 minus G evaluated. Now, if you have this typed into your graphing calculator, you can just use your calculator feature, calc value, and you can go ahead and type in 8. I don't have the right equation in, but if you do, you type in 8, press enter, and it's going to spit out a number here. 8 into here and 8 into here. I like calculator as a y sub 1, just so I don't make any calculator mistakes. If you use a calculator for f of 8, you're going to get approximately 48.4170. Again, I would use at least 4 or more decimal places. You don't want to round and round, because then you'll get a rounded answer and it will not be accurate. Is equal to 8 here, it's going to be 108. That is approximately what? I'm going to give you a negative 59.3. And what is the unit on that? Rate is cubic feet per. Example number 2, that is just like example number 1. You do not need a calculator because you can evaluate these. By example number 2. rate of the amount of penguins is equal to the first derivative. Those are the same thing, which is your rate in minus your rate out. Your birth rate minus your death rate. They want R of 0. So that's B of 0, and the death you have 250, so that's 750. The rate, so it is penguins per year. Now I definitely would go ahead and read example number and store your rate in as your y sub 1 and your rate out as your y sub 2. So go ahead, pause the video, read the paragraph, and store the functions into your calculator. Welcome back. I hope that you did store those into your calculator, and your rate in should be the 3 plus 2.14, and the rate out is the one that starts with the 10. Rate in, rate out. These are going to be one of the first two questions on the AP exam. There are two calculator questions, and there's a good chance that it's going to be a rate in, rate out problem. We are only doing pieces of the actual free response because you do not have enough knowledge to do all of the pieces. The free response questions are for the entire year, the content. So we're just taking pieces of those questions. You can see that this is from the 2017 exam. This was on the AB and the BC exam, and we can do parts A and B with what we know up to this point. Okay. So it says find f prime of 7. Well, we already have f stored in our calculator. So let's go over, and on the second page of the notes, it tells you how to do this, but let's refresh your memory about the derivative. Math 8 is where you will find the derivative. You're going to take the derivative with respect to x, or variable. In this case, it's t, but x is fine. Now, instead of typing in, again, we're trying to save you time, because on a free response question, you have about 4 parts. It's usually A through D, sometimes E. We're going to insert our f. Now, if you recall, our f was our y sub 2. It was our rate out. So if you hit your vars button here, and you arrow over to your y variables, and you choose number 1, the functions, you can input which one you want, your y sub 1 or your y sub 2. And again, in this case, we want our y sub 1. I'm looking, oh no, we want our y sub 2. That's what I thought. Y sub 2 is our f of t. So let's go back here. So we want to insert our y sub 2. So that's your here, so you don't have to keep typing it into your calculator. And then you can use it whenever you need it. You want to evaluate that at x equals 7. And that's what you should come up with. Now, the only thing you have to write on your test when you're doing the free response, you don't have to say, typed it into my calculator. You can just say f prime of 7 is approximately equal to 9, 5. Again, I like to go to at least 4 to be truncate. It's completely up to you. Another one on there if you want to. That's 5. And use the correct units. Now we took the derivative of f, and f is measured in pounds per hour. That's what f is. And t is the number of hours. So if F is pounds per hour and T is the number of hours, what is F prime? It is pounds per hour per hour. Very similar to what we did with motion. So that is the correct unit. Now explain the meaning. Explain the meaning. Now remember, we're going to use we have to use our noun. So F prime is what? It's the rate, right? It's a rate. The rate at which customers are removing the bananas. The rate which moving the bananas Now, this is the derivative of the rate. Okay, so this is a rate. You took its derivative, and you're going to get another rate. The rate at which the customers are removing the bananas from the table, because this is negative, this f of t is decreasing. So if you want to think of it, this is your velocity in a sense, and this is your acceleration. Your acceleration is negative, therefore your velocity is decreasing. The rate at which the customers are removing the bananas from the table is decreasing by 8.1195 pounds per hour squared. Okay, and then at what? At time E equals 7. 7 what? 7 hours. Okay. Then part B says, is the number of pounds of bananas the number, so that's the amount. Okay. Is the amount of bananas on display, on the display table, increasing or decreasing? So if we want to know if our amount is increasing or decreasing, we need to look at the rate at which they are being added and removed. So this, again, we're going to be looking at the derivative of the amount, which again is our rate on minus our rate off. So that's going to be G of t is the rate that they put them on the display, and we're going to remove them. F is the rate at which you remove them. So this question is similar to examples 1 and 2. They want to know what G of 5 minus F of 5 is. Okay. Let's show you how to evaluate that in your calculator. Go to second calc and then value, as I said before. We want to evaluate it at 5. Now we want to evaluate each one at 5. So if you look up here, it will tell you that you're evaluating your y sub 2. This equation is being evaluated at 5. So this equation is our f of 5. If you arrow over and That's turned on. So let's try that again. There we go. Learn from my mistakes. Make sure both of your graphs are turned on. Let's try this again. We're going to calculate the value at 5. So y sub 1 is your 3.2. I'm sorry, 3 plus 2.4. That equation right there, which is our g of t. So our y value on the graph is 11.5, approximately 11.5. Anytime you use your calculator, say approximately 3, 8 minus, I just arrowed up and I went to the second equation. That's our f of t, and our answer is 13.7959. So that is 13.7. 2.2631. Okay. Or you could say g of 5 is less than f of 5. So your rate on is less than your rate off. So if your rate on is less than your rate off, or the rate is negative, that means that your amount of bananas is decreasing. At time t equals 5. In this case, what is the unit? 5 hours. So that is similar to the motion problems. If your velocity was negative, you were moving in a negative direction, your distance. Same thing with acceleration. If you're taking the derivative of a rate, this is your acceleration. And if your acceleration is negative, then let that sink in and we'll try some more problems.